I'm Anna. I work at Chemistry Department, University of Sheffield. I'm postdoc at GrahamLeggett Group, and I'm working on fabrication of gold nanostructures. This video will introduce you to the technique of interferometric lithography, which enables the fabrication of well-defined gold nanostructures with a wide range of morphologies over square centimeters areas. First, clean your glass slide and vial with piranha solution. Piranha solution is a mixture of 30% hydrogen peroxide and 70% sulfuric acid. It must be prepared with great care, and surfaces must be clean and completely free of organic solvents. When the solution has stopped bubbling and cooled down to room temperature, carefully dispose of it in a dilution tank. Rinse the slide and vials with water. Sonicate for 2 to 3 minutes, rinse again, and place in the oven to dry. Once dry, using a thermal evaporating system, the slide is coated with a 5 nm thick chromium film, followed by a gold layer approximately 20 nm thick. Whilst this takes place, prepare a 10 mmol solution of octadecanethyl in the gaseous ethanol. Once the evaporation is complete, the coated glass slide is immersed overnight in the oddity solution to form closely packed self-assembled monolayers. Prepare the slide for UV exposure by rinsing with ethanol, blow drying with nitrogen, and cutting it into small pieces. The sample is mounted onto a Lloyd's mirror interferometer, and a 244 nm UV laser is used as a source for photolithography. The laser is directed so that half the beam hits the sample and the half the beam hits the mirror, from where it's reflected onto the sample to interfere with the first half of the beam. An interferogram is created that consists of parallel lines of constructive and destructive interference. This selectively photooxidizes the self-assembled monolayer of octadecanethyl. We use a double exposure process. By varying the angles of rotation between exposures and between the sample and mirror, we can create a wide range of morphologies. Finally, the photopatterned monolayer is aged by immersion of 2 mmol of cysteamine hydrochloride in ethanol with added ammonia, and gold nanostructures are formed. Rinse and dry the sample one last time. The dimensions and morphology of the fabricated nanostructures can be obtained with AFM. Analyzing the UV visible absorption spectra of gold nanostructures shows a characteristic peak around 520 nanometers associated with localized surface plasmons. Large red shifts are observed in these bands after attachment of biological molecules. For example, a shift more than 15 nanometers is observed after attachment of bacteria chlorophyll A. Fabricated nanostructures has unique optical and sensing properties, and because of these properties it has wide area of application, starting from biosensing, medical diagnostics, data storage, or it can be used for better understanding of mechanism of photosynthesis. The technique we demonstrated has a lot of advantages. It is very fast, it is very cheap, and we have great control over morphologies of fabricated gold nanostructures, and can be easily adapted in basic labs, and had a great promise for future investigations.